In 5-5, we're going to do two things, apply double angle formulas and half angle formulas. So let's start with double angle identities or formulas. There are going to be times where it's useful to use the value of twice an angle. Looks something like this when we have sine of 2x instead of just sine of x. Like this has just cosine of x. This is doubling that angle, whatever x is. There are situations that this pops up in more complicated problems, some calculus ideas, so it's good to be familiar with those identities here. These again are on your reference sheet. Here's all of them right there. So we see sine of 2 theta, so we see a double angle there. Cosine 2 theta. Now cosine 2 theta actually has three different ones, all of which can be used. More often than not, I just tend to use this one, but all of them work, and it just kind of depends on the situation. And then there's one for tangent. I'll also show you a little shortcut for tangent as well. There's another way to do it, but here is a formula for also doing tangent of 2 theta. Here's the most common situation you're going to come across, and they're going to ask us if sine of theta is 3 over 4, so we have a ratio, and theta has its terminal side in the first quadrant, which is good information to know what quadrant you're in, make sure sign's different. Find the exact value of each function. So the exact value of sine of 2 theta, cosine 2 theta, tangent 2 theta. So what you need to do first is we have this ratio. Well, let's do like what we've done in the past. Let's set up a triangle. If I have a triangle, sine, cosine, and tangent work on right triangles. I'll just put theta over here. You can put it anywhere. Sine is the opposite over hypotenuse, so the opposite side is 3, this side is 4. If I use Pythagorean theorem, I can find the missing side. 3 squared plus something squared equals 4 squared. Keep solving, you'll get 16. Move that 3 squared over 9, you should get 7. When you square root, we get x equals square root of 7. So that's the missing side. That's going to come in later. So let's go back over here. We want to find the sine of 2 theta. So if I use my formula, sine of 2 theta is 2 times sine times cosine. Okay, so 2 times sine times cosine, I'm just going to fill those in. Well, the sine ratio they gave me, sine was 3 over 4, and the cosine ratio, if I look at my triangle, is root 7 over 4, the adjacent side over the hypotenuse. So root 7 over 4. Sorry for the little crappy looking square roots. All I have to do is just multiply this together. Just remember that this 2 is just like saying 2 over 1, so it only multiplies to the top. So 2 times 3 is 6 times root 7, so this becomes 6 times root 7. Don't forget the bottoms, 4 times 4 is 16. If we reduce the 6 and the 16 on the outside here, that becomes just 3 over 8. So 3 root 7 over 8 is the fraction that I'm looking for. That's sine of 2 theta. That's the exact value, no decimal. Okay? Notice I didn't find the exact angle or anything like that. I'm not worried about that. It'll probably be a weird decimal anyways. What I'm looking for is the exact value of the ratio of these sides. If we're looking for cosine 2 theta, well, I'm just going to pick one of those formulas. Like I said, there's three. Any of these will work. I like this one the best because you'll already have things squared. It'll get rid of any weird negatives, and they'll have the same denominator already then. So I just got to fill it in. Remember, cosine squared theta is like saying my cosine value squared. So this again is my cosine ratio, and I'm just squaring the whole thing. Sine squared theta, I'm taking my sine ratio from before and squaring it. So I got to square top and bottom. Root 7 squared is just 7. 4 squared is 16. 3 squared is 9. 4 squared is 16. Hey, look, these are fractions that already have the same denominator. 7 minus 9 is negative 2 over 16, which reduces to negative 1/8. And lastly is tangent, and this is where I was talking about there is a formula, but there's actually a shortcut. If I've already done the work to get sine of 2 theta and cosine of 2 theta, well, we know that tangent is sine over cosine. So tangent of 2 theta would be equal to sine 2 theta over cosine 2 theta. So it's kind of a shortcut formula once you've done the other two. If I was just looking for this, then I would use the formula on the previous page. But I've already done these, make my job easier. So if I fill that in, sine of 2 theta was this guy, 3 root 7 over 8, and I'm dividing by the cosine, which was from before, negative 1/8. If I divide by a fraction, you multiply by the reciprocal, so 3 root 7 over 8 times negative 8 over 1. The 8's actually cancel out. Cancel those, boom, boom, boom. So I got basically negative 3 root 7, and that's the exact value. So that's the most common example. You'll definitely see an example like this on your quiz and your test. The other place we can use this is when we're solving an equation that involves a 2 theta. Basically, as soon as you see something like this, you're going to want to replace it. You can't like take that 2 out. You can't divide by 2. It doesn't work that way. So as soon as you see this, you want to replace it with, in this case, since it's cosine, we have 3 different things that we could use. Now in this case, I'm going to actually replace it with, whoopsies, on there, move that. If I have this formula here, I'm actually going to replace it with this version of the 3. Because I already have a cosine, so I don't want a cosine and a sine, and I don't want to have just put a sine squared thing here. So I'm going to use the one that involves just a cosine squared. That way everything is cosines. Since I have cosine squared, a cosine, and a 2, I'm going to get everything on the same side. So I'm going to minus the 2. I'm going to combine like terms and just kind of reorder everything. So 2 cosine squared minus the cosine. Negative 1 minus 2 is negative 3. And I'm going to start solving. This can actually be factored. It'd be 2 cosine and cosine, that'll work for this. To get 3, it's a version of 3 and 1. In this case, negative 3, positive 1, because this will make 2 cosine, this will make minus 3 cosine, which will give me the negative 1 cosine here. Once it's factored and equals 0, we set both parts equal to 0. And there we go, set both parts. I'm going to add the 3, divide by 2. I'm going to minus the 1 over here. So if I look at my unit circle, cosine of what angle gives me negative 1? That answer is 180 degrees. Over here, 1 is cosine 3 over 2. You'll never see this on the unit circle. 3 divided by 2 is 1.5. That's too big. That doesn't work. So this one we would just cross out. This is basically some sort of extraneous solution, but we do have our answer right here. This angle has to be 180 degrees. And that's it.